Hi, I'm Scott Beibin of the Mandelbot Ecotech project, and right here we're looking at the Mandelbot SURFA. And the SURFA is an abbreviation for the Scalable Universal Robotic Frame Assembly. What that means is that this is, while a 3D printer, it can also act as other things as well. So right now it's in the configuration of being a 3D printer for food. In here is some almond butter, and we're working on actually being able to print onto cookies. So we have some organic or bio cookies right over here. And yeah, so I'll tell you a little bit about this project. I've been thinking about the environmental implications of manufacturing for a while, thinking about how the globalized system of distribution of manufacture is just so harmful to the environment, where you have a part made here, shipped all over the place, or you have something mined in one part of the world and then it's shipped to another place and just it goes everywhere, and it winds up costing the environment and making it more, I guess, more difficult for us to have a livable biosphere. And so, while thinking about this for a really long time, I was, thinking like, well, what would be the best way to encourage people to change their behaviors such that they're not so reliant upon this globalized system of distribution, where we can relocalize manufacture, and not only relocalize manufacture, but also use more ecologically sound materials in manufacturing. So we came up with this kind of multi-faceted platform called the Mandelbot SURFA at first. Now, this printer, this device, is actually a scalable frame, meaning that it was designed so that you can change the dimensions of it very easily to your wishes. So you can change the X dimension, which is across, you can change the Y dimension, which is the depth, and then you can change the Z connection, which is the height. It was designed such that we have these nodes over here. So these nodes are all symmetrical. And so this side is an exact copy of this one. Not even a mirror image, but an exact copy of this one. This end over here for the X is an exact copy of this one. Then you have these extenders, which are exact copies of each other. And then you have this motor block, which is just at the center, and it's kind of like this symmetry. And the same thing with all the lower parts of the printer, including the Y. One of the other goals for this is to have it be under 100 parts. So we've succeeded in that goal. This is just about 100 parts. I think we have 97 parts right now. Kind of lost count. But yeah, but anyway, that's our goal. And all the plastic on here is actually made from compostable materials. So this is PLA, polylactic acid, which is made from plant matter. So what are some of the other features I can tell you about? So it's also very portable. So let me move this up here. So you can fold it and stow it. Also, it has removable parts that are easily swappable. So right here, this is the goo extruder, which extrudes goo. And inside of the goo extruder, we have some almond butter right now, and this is inside of a syringe. So this is a basic linear actuator where the base and the top of it are 3D printed, and it uses standard off-the-shelf parts. So this is an 8mm smooth rod. This is an 8mm threaded rod, and this is a geared stepper motor And the reason why I use a geared stepper motor is so that it can very easily extrude thick materials, whether it's something like almond paste or ceramic. Or you can also use other types of biological materials. So you can use this not only for making food or for pottery and ceramics, but also in the lab, where you can have, I guess you can extrude exact amounts of a sample into a petri dish or whatever it is that you need to do. And the other thing is that we have these hot shoe camera mounts. So I used to be very involved in the film world, so I knew all about these wonderful camera mounts. This is actually a copy of a Manfrotto mount, and I thought, we'll just put this on here and be very easy to snap on. Let's see. Of course, there we go. Okay. So, the other thing about this that's, I guess, kind of unique, let's see, we'll move it down a little bit. So I was thinking about how to affix the X carriage such that you can take it apart very easily. So this printer is, it's really tightly held together, and you wonder, well, what's actually holding it together? As you can see, there aren't any metal fasteners holding the top bar or the bottom bar together. So what's holding it together? Well, here's the unique thing about it. Basically, we can take off the X carriage because we actually use neodymium magnets. So this is a magnet right over here. There's a magnet over here. And so it will slide in very, very easily to the carriage, and you slap it together. And once it's slapped together, it's very, very difficult to pull apart. So it's actually very easy to keep this level. And let's see. And so I wanted to give a huge shout out to my design partner on this, the ever illustrious Lucian Chapar, who is an absolute genius when it comes to machine design. It's been a pleasure to work with him on this project. It's always important to have a really good partner who's able to put the work in and has amazing skills. So I just wanted to give him a huge shout out while talking. There have been other people too that have worked on this project as well. The original idea I was from Virginia Ozymandias, who gave me the idea of creating parametric machines in the first place, and then of course Zabby James, who originally we were talking about making a 3D food printer back in 2010. We were at Hackers on Planet Earth and brainstorming, or maybe it was Burning, I don't know, where we're somewhere and we're brainstorming about making a 3D food printer. And the whole purpose of this really was to be used in the Groucho Fractal show. Groucho Fractal is a performance that I do, which is a bicycle-powered stage show where audience members use brain-computer interface to make 3D printed organic vegan snacks on a bicycle-powered 3D food printer. So I didn't have any of those things at the time, so I had to invent a lot of them. I also had to meet people who were making these things. And so thus began a huge journey. So anyway, now I have this 3D food printer. The other thing about it too, which makes it ecologically friendly, is that it is low power, so you can power it via bicycle. So you can basically pedal a bicycle, and I have a power unit that I developed with a few friends that has batteries and supercapacitors combined, so that you pedal, you charge up the pack, and then you can run the printer. It's actually easy to run this printer with this configuration because we don't have a hot end. We don't have a heated bed, which tends to take up a lot of the electricity. Really, all we have on this are 4 stepper motors. So it's fairly simple to to power. Oh, also we have this microcontroller. One of the other things too, which was a very important design decision, was using a RAMPS 1.4 controller board on top of an Arduino Mega 2560. Now, the reason for that is that this is cheap and ubiquitous. You can buy these for $5 very, very easily. And so I wanted to make this printer very accessible. Somebody could just take something that was already in a hackerspace or they might have in a drawer and get it running. So a lot of the inspiration for this project comes from, awesome projects like Linux, like open source ecology, and RepRap, of course. This I would say it could be considered a RepRap. I would hope it would be considered a RepRap. And it's a potentially self-replicating 3D printer. Yeah, so these are all the different aspects. And right now, what I'm trying to do is race against the clock so that we can actually print some snacks, some cookies for Miranda's birthday, which we're having here at SGMK summer camp. And these are some plant-based organic cookies we have on this print bed. And what I'm about to do is I'm about to set the dimensions basically so that I can control where the print is going to go. So we're going to program that, and I'm going to be sending the coordinates over to Lucian so he can write a lot of the G code that we're going to need for the printer. So right now, first we're going to home it in the process. So by homing it, it means we're going to go back to base. So right over here, this is a mechanical end stop. And when we reach the mechanical end stop, it's going to tell the X carriage to stop moving up. So we're going to move the X carriage along the Z coordinate. And here we go. Hopefully it'll work. Yeah, I guess in the immortal words from the movie Spaceballs, even in the future, nothing works. Let's see. So let's try to program this right now. Okay, you move it down. 1, 2. Okay, we'll rehome it. One of the issues might be that it could be buckling. So we'll try to redo that. Let's see. So I'm going to unplug the power real quick so that I can readjust this, get it leveled. Unfortunately, I don't have a level on me, so we'll just have to eyeball it. Seems okay to me. So I'm going to plug it back in. The reason why you don't want to have this plugged in, especially with one of these older microcontrollers, is that if you run the motors, you'll get electricity going back into the board, and that can fry out the polulus, or the stepper motor drivers, which are right over here. And we don't want to do that. I used to go through so many of them. Anyway, yeah. Okay, so we're plugged back in. Let's see what happens. Probably unplug it too. Maybe it's having some issues because of power. Sometimes it's just better to reset. Okay, so I'm plugging back in. It should show up on the screen in a second. Aha! Okay, let's see if it works. Okay, we're going to move 10 millimeters down. You know, the actual motto for Mandelbot is that 3D printers are for people who love fixing 3D printers. Okay, let's see. Okay, now it's moving again. Sometimes it just takes a little bit of fiddling. Okay. So now what we're going to do is we're going to find the exact position over here on the left bottommost cookie. So we're going to count the amount of steps. I'm going to open up a text document right now to count the steps. Getting over there. Okay. Sometimes it's better to count individual steps. So I'm going to do 1 millimeter at a time. That's, I guess, a step in this case. So let's go. Okay. I'll go down. Let's see. I think what I'll do to do this the right way, I think I'm going to move the Y bed first. So I'm keeping this kind of steady right over here, just kind of eyeballing it. And what I'm doing is I'm having a level basically come down from here. So it's like a plumb line right here. Okay. So I'm going to move the bed forward. 1, 2, 3, 14 millimeters over. Now we're going to move the Z down. Okay. So 1, 2, 3, 4, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. Oh, sorry. 145, 146, 147, 148, 149. Let's just say 149. See 149. Let's say 148, 149, just in case. Okay, now we're going to move the, I'm going to move this up one click. So we're going to move over the X, 1, 2, 3, 4. Okay, 16. Yeah, that looks about right, 16. So the X is 16 millimeters. Okay, now it looks like we need to move the Y back a little bit just to see. So, wait, that's wrong. So we're going to subtract, so we'll say 13 millimeters for the Y. Okay. And we can double check our work. Let me move it down onto the cookie a little bit. I'll increase the amount of clicks. Okay, as he goes down. 149. Okay, 150. With the goose shooter, it's actually a little bit different than printing with the plastruder, because you don't really need to be as precise. It's not printing with a tiny little nozzle. It's actually a pretty big nozzle. You can kind of see it is. Let's see, how many? So it's like 3.61 millimeters on the exterior. So it's like really technically it's about 3 millimeters in the interior. Yeah. Anyway, so what I'm going to do is I'm going to send these coordinates to Lucian, and yeah, so it's pretty good. I'm going to take a picture and send to him and see what he can do. it's kind of amazing being able to coordinate with people across the world using the digital interwebs. Let's see, I'm going to send this to Lucian right now. Okay. Perfect. Okay. And I'm going to send the coordinates. Let's see, 13 millimeters for the Y. Okay. Yeah, so I don't know, I like being able to actually like coordinate with other people when working on stuff. I should probably be able to do this myself, but you know, I really like collaborating with people too. Okay, so actually what I need to do is I need to measure to the center of the cookie. So what I'm going to do is I'm going to measure it with calipers. These are my cookie calipers. Actually, that'd be great. I should have MandelBot branded cookie calipers as merch.
That'd be great.
Yeah. Okay, 44.3, so let's see. So I'll move it back a little bit. I'm going to move it all the way over. Move it up a little bit. Okay. That looks about centered. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh. 2, 3, 4, 5, 6, 7. Oh, whoops. 2, 3, 29, 30, 31, 32, 33. 34. 35. 21. Oh, yeah. I have to move this over. 35. Okay. And then I'm going to move this over. That's 13 millimeters. It's all very fiddly. Okay, 13, so 14. So now we have 21 and 21. I feel like I'm working in a snack factory with my cookie calipers. 22, 22. Yeah, that seems about right. Measure from this way. Yeah, that's good enough. 22. Okay, so let's count it backwards. Okay. All the techniques involved in precision cookie engineering. Precision cookie engineering is a very, it's very tasty endeavor. Okay, let's move this back. So count out how many there are. Okay, so there's okay. So it's 1, 2, 3, 16, 17. 17 steps, roughly. Actually, it's 16 steps. 17 steps. Okay. Look at that. 17 steps. Oh, actually, Lucian is saying that these are Cartesian cookie coordinates, CCC. Of course. Okay. So center would be better. Okay, so it's, tell him it's Y is 17 millimeters. Sorry, X is 35 millimeters. Y is 17 millimeters. So amazing. I just love the fact that I'm able to communicate with somebody halfway across the world. At some point it'll be great because, I'll be going back and forth with my friends who are on Mars, but the delay between coordinates, it's going to be anywhere between 7 and 16 minutes. It's going to be so annoying, or probably it'll be a bit longer because that's actually direct, because, you'll wind up having, probably in the future, you'll have these different services that it'll take longer for a signal to reach Mars because you'll have it bouncing off of these different satellites that are all over the place. And then you're going to have all these annoyatrons, probably these, terrorism in the future will probably be these companies that send these giant extendable sails out into space that wind up blocking the signal coming from Mars. And everyone will be like, oh, that's so annoying. And then they'll send the space fleet out to have the sail device go away. And then the sail device will know that the space fleet is coming, and they'll close the umbrella and go hide behind some asteroid. And they'll be incredibly annoying, of course. Yeah. Annoyatrons are very, very important in the world of science fiction. And this soon will be science reality. Of course, it'll be a culture jamming experiment, and yeah, but we can make these delay tolerant networking jokes later. This is no place for jokes about delay tolerant networking. Oh wait, actually, this is exactly the place for jokes about delay tolerant networking in space. Look at where I am. I'm around all these other crazy people. Okay, so let's see what Lucian says. He says nothing yet. Okay. I'll take a picture of it and send it to him. This is so exciting. I just love doing stuff like this. I'll send this to him. Maybe we can get him on video too. Let's see. I'll ask him if he wants to be on video. I'm calling him right now. So let's see if he picks up. Hey, Lucian. Hey, right now I'm being interviewed for the video about the SGMK summer camp. And this is Christopher.
Oh, cool.
And this is Robert.
Hey, Chris.
Yeah.
Hey, Robert.
Yeah.
Nice to meet you too.
Yeah. This is my co-designer on the Mandelbot Surfa Alpha and a whole bunch of other versions that we kind of banged our head against the wall with for a long time. Yes, and so I actually have you mic'd right now, and
Oh, no way. That's awesome.
yeah. So, do you want to say some things? I was actually just going through the process of homing and setting the coordinates for the goose shooter. Do you want to talk a little bit about it? It can be as technical as possible. We were actually just making jokes about delay-tolerant networking in space.
So intelligently here, but so basically, for the past hour or so probably, I've been having Scott figure out the coordinate plane and coordinate origin point for the cookies. So we have cookie 1, 2, and 3. And from that, what we'll be doing is offsetting however many millimeters of jumping he had to apply to the machine to get in the right spot. So I think he said it was 17 millimeters for X. So I'll add that value. And I'm basically just walking the cookie test models into the correct spot on the machine, so that when I send Scott G-code, it hopefully doesn't turn the cookies to dust. It's a whole thing, as all of us probably know, to align virtual coordinate system to like the actual like locations, right? So yeah. We're having fun here. We're gonna print some goo.
Yes, we will be printing with goo. Maybe we'll have some birthday goo for our birthday lady over here. By the way, here, check out all the interesting things that are happening right now.
Yeah, let's see.
Yeah, it's pretty cool. Yeah, this is a.
Music, or it's an ungodly noise.
Oh yeah, yeah. Everyone's tinkering around with modular synths and doing some circuit bending. Yeah.
MandelBot.
Well, one of the goals for being here is that I'm going to try to get the MandelBot printing while making music. So we're going to do, yeah. So yeah, it'll be great if we have, I guess, the Death Star theme or whatever while printing the cookies.
Cool.
Yeah, or something like that. Okay. So do you have any wise words of wisdom before I hang up?
The best thing I can say is keep your finger on that east out button. Let's hopefully not crush some cookies.
We're cookie crushers, yeah.
Other things of wisdom, just keep at it, man, because, my God, if we dealt with some shit to get this printer to where it's at right now here at the event.
I know it's...
Scott's done an insane amount of work, grinding far longer than I probably would have, and it's really impressive. Like, you should be pretty proud, man.
Thanks a lot, Lucian, and you've done a tremendous amount of work too. I mean, it's been a team effort and a really fantastic one. Love you, man.
And
Yeah.
And especially like shout out to everyone there at the event that's been a part of helping Scott like get this machine to where it's at. We certainly could have done everyone at the crew. Everyone.
Awesome. Yeah. Well, it's all about collaboration and teamwork and teaching each other the important skills, especially because we're trying to save the planet or the biosphere.
One of the funniest things about MandelBot that I did not realize when I first got on this project was like how many different types of people it brings together. It takes a very intersectional skill set to achieve what Scott envisioned for the project. And the places in the world it takes you, the people you meet, and the technologies you have to touch and interact with, it keeps me on my toes, and it gives me being creative and imaginative. It's always fun.
Yeah, thanks a lot, Lucian. Yeah, thanks for sharing that insight. Yeah.
For sure. I'm probably gonna hop off this call and focus on the sauce.
Okay, cool. And do one for the double stack cookie and one for the single stack, and we'll test it out. Okay. Okay.
You're doubling up the work. I'm gonna pick the double stack to start.
Do the single stack to start. Do the single. Okay. Okay. Talk to you in a bit. Okay. Bye-bye. Yeah, I guess that's one of the best things about like having people around who are like fantastic to work with. Like, I hope we get to work together. You have such like a good energy about you, and I don't know. I feel like you get the complete insanity that this thing represents. It's kind of like, I guess, the anti-capitalist machine or something like that. Yeah.
Yeah. First step in the direction of making it accessible.
Yeah. Yeah. One of the parts that I left out about this that I'm working on. So this, aside from this project being parametrically designed and scalable, there's a specific reason for that. One is that I wanted us to be able to make the scalable printer. Now, we can just export the files. I mean, we will be able to do that so that people can have the cut files, the build files, and the programming for the microcontroller. But in addition, one of the other goals is to also have a smart contract. So I want to actually produce NFTs on some blockchain that can support NFTs, where we output all those files and then add an additional component to it of governance. So one of the things I'm a huge fan of is collectivism or cooperativism or other types of voting systems or like, I guess, governance and human organizational systems that allow for greater fairness in projects, such that we have things like quadratic voting and all these other types of interesting experiments. Yeah. And so a lot of the technologies that come out of the cryptocurrency realm, like blockchain tech, allow for this type of organizational system to become scalable. So we can experiment with that scaling process. And that's one of the things that we're going to be doing with MandelBot, is that we're going to be exporting those files onto a smart contract and figuring out how that actually works. And by default, it will allow people to organize collectively versus in I guess hierarchical ways. And the people will, if they want to actually do stuff where they have hierarchies, they'll actually have to hack the code themselves to do it. But by default, it's horizontal and designed to be fair. And I'm sure that's going to infuriate a lot of people, but I think that it's really important to challenge people to think about these things. But yeah, that is, I guess that's in a nutshell the MandelBot project. Coming up soon, we have the MandelBot Hab, which is a 3D printer for ecotexture. That's large-scale 3D printing of buildings using natural materials. And that's like a whole other project. And also, I'm working on a platform for flying electric vehicles that are also scalable, where all the engineering and other aspects are programmed into it. So, yeah, I'm just kind of hoping to inspire people to start thinking about design in this way, where you're not just looking at an object and thinking like, oh, that's a toaster, oh, that's a speaker. But I want to start having people think about every single object that's been designed that uses mining or like extraction or any of this stuff that brings these wonderful materials to us, to start thinking about all these devices as multi-purpose materials or multi-purpose devices that are easy to repair, easy to build, easy to reuse the parts and recycle everything, and such that we stop thinking about anything really as waste, and that everything itself is a resource. We have to kind of go back to that way of thinking so that we can survive and that we can start to thrive and travel to other planets and avoid making a lot of the same mistakes that we've made over the past 150 years or so. But we can correct it, we can figure things out. But yeah, over and out. Thank you very much to SGMK. You guys are amazing. CCC, you're amazing. So happy to be here and honored to be a part of summer camp. Yeah, Homemade Summer Camp is really such a great event. I can't wait to come back in future years. Thanks. Oh, at mandelbot.io, mandelbot.io, and you can find MandelBot Ecotech on any of your favorite social media things. Okay, and maybe you'll be eating some goo from the Goostruder in the future. Okay, bye. Oh, last thing I'll leave you with. The reason why it's called MandelBot is not only because we're printing with almond paste, but also it's a tribute to Benoit Mandelbrot, who described the Mandelbrot set of fractals that are named after him, that are scalable, iteratable, modular. So the printer was designed to follow a lot of those patterns that we find in nature. Yeah, keep looking up. Thanks so much. Mandelbot.io. My name is Scott Beibin, spelled SCOTTBEIBIN, and that's Scott, SCOTT, at mandelbot.io. Okay, thanks, bye. And at Groucho Fractal, if you want to contact me on social media. Thanks.